In this lesson, we're going to solve equations of this form by factoring. But before we get started on the solving, first we're going to practice factoring. This first example says to factor the trinomial x squared minus 9x plus 20. So to do so, we're going to use a t-chart. And with this t-chart, I have a little phrase. So the way it works is it goes up and down left, up and down right, crisscross adds to the middle, and our answer is left to right. So when I say up and down left, we're asking ourselves what times what multiplies to make the term on the left. So we're going to use x times x, which makes x squared. So that was our up and down left. So next we're going to go up and down right. So we need to think what times what multiplies to 20. So obviously we have 1 times 20, 2 times 10, 4 times 5, but you want to keep in mind what will combine to this middle term. So we're going to use 4 and 5. So next it goes crisscross adds to the middle. So if we multiply this, we get 4x, and when you multiply these, you get 5x. We need these terms to combine to this middle term, so to do so, they both need to be negative. So next we take this negative and we put it in front of the 4, and we take this negative and put it in front of the 5. And before we keep going, we want to double check, does negative 4 times negative 5 in fact multiply to positive 20? And it does. So our signs are good. The last part of the phrase goes, our answer is left to right. So our answer is going to be x minus 4 and x minus 5. So our original trinomial expression factors to x minus 4 times x minus 5. This example says x squared minus 4x minus 12. It goes up and down left. Next, we're going to go up and down right. So you have 1 times 12, or 2 times 6, or 3 times 4. We're going to glance at the middle term, and because we have a 4 here, we're going to use the 2 times 6. Next, we go crisscross adds to the middle. So we need 2x and 6x to combine to become negative 4x. So that means the 6 will be negative and the 2 will be positive. Once you identify the signs, go ahead and fill them in. So this 2 gets a positive and this 6 gets a negative. And your answer goes from left to right. So one more time, the phrase goes up and down left, up and down right, crisscross adds to the middle, and your answer is left to right. Up and down left is going to be x times x. So up and down right, we have 1 times 18, 2 times 9, and 3 times 6. But when you glance to the middle term, we want to use the 3 and 6. Next, crisscross adds to the middle. So we need a positive 3x. This makes 3x, this makes 6x. To get a positive 3x, we want the 6 positive and the 3 negative. You always want to check these numbers do in fact multiply with their signs correctly to this last term, which they do. A positive times negative is a negative. And finally, our answer goes from left to right. So we get x minus 3 times x plus 6. So let's start the process again. We go up and down left. We're going to go up and down right. So again, you can use 1 times 36, 2 times 18, 3 times 12, 6 times 6. And because of the middle term, we're going to use 6 times 6. Also, if you'll notice, both of these signs are positive, so that means both of these are going to be positive. So your answer goes from left to right. So I wrote it out like this, or we can write our final answer as x plus 6 quantity squared. This example looks a little different because we're missing the x term, but you can still use your t-chart. Up and down left still works, so you just fill in x and x. Up and down right works. We have 7 times 7, and in order for there to be no middle term, we're going to make one of these 7's positive and one negative. This way you have 7x, take away 7x, and those cancel, leaving you with no middle term. So our final answer is x plus 7 times x minus 7. So as a backup, you have your t-chart to factor all of these expressions. I do want to point out the factor pattern that does occur in this problem though. We have x squared minus 49, and this is also called a difference of squares. So you have x squared and then you have 7 squared. And then there's a minus in between. So anytime you have a difference of squares, I just want to point out you can use this factor pattern. If you have anything of the form x squared minus a squared, it factors as x plus a times x minus a. So keeping that in mind for this next problem, we still have a difference of squares right here. You have a squared minus, and this is 5 squared. So using the difference of squares factor pattern, we're going to go a plus 5, and over here is going to be a minus 5. So this is your answer using the difference of squares pattern. Next, we're going to work on actually solving equations. So the big difference between the previous problems and these upcoming ones, for the problems we just finished, the direction said to factor the expression. So if the directions say to factor, you're leaving your answer as a product of factors. So you have your parentheses and you leave your answer just like this. So for these next examples, the instructions say to solve. So that's going to be important, is that when we solve, we're going to then finish the problem and get answers in the form of x equals a value. So this example says solve the equation. So what we're going to do is we're going to factor this left side. So we're going to factor using our t-chart. We're going to go up and down left, and we're going to go up and down right. So we're looking for two numbers to multiply to 28, that when we combine them, we get 3. So we're going to use 7 times 4, which makes 28, and let's fill in the signs. We need a positive 3, so if we have positive 7x, take away 4x, that will give us positive 3x. And then we can double check, positive 7 times negative 4 does make negative 28. So now we have the expression x plus 7 times x minus 4 equals 0. So next we're going to apply what's called the zero product property. It says that if you have a product equaling 0, you can set both of the factors equal to 0. So I have x plus 7 equals 0, and then I have x minus 4 equals 0. Finally, we're going to solve this linear equation. So we get x equals negative 7, and over here we're going to add 4 over, so you get x equals positive 4. So you end up getting two answers, negative 7 and positive 4. For this example, we have m squared equals 7m. We want this equal to 0, so we're going to move this positive 7m to the left side of the equation. So I subtracted the 7m over, so now we have m squared minus 7m equals 0. To factor this, we're going to use a GCF, what is common in both of these terms that we can factor out to the front. And you'll notice that you can factor an m. So when you factor out an m from both of these terms, you're left with m minus 7. At this point, we're going to use the zero product property. We have a product equaling 0, so we're going to set both products equal to 0. So on this left side, we just have m equals 0, and there's nothing left to solve. On the right side, we're going to add 7 over, so we get m equals 7. So our final answer is two values. We get m equals 0 and 7. For this next example, we want this equation equal to 0. Since this x squared term is already positive on the right side, let's go ahead and move these terms over to the right. So we get 0 equals x squared minus 6x plus 9. Next, we're going to factor. According to the zero product property, we can set both of these equal to 0. And when you do so, you get x equals positive 3. This problem says find the value of x, and it gives us that the area of the rectangle is 36. So we have one side has a length of x, and the other side has a length of x plus 5. So what we're going to do is we're going to take the area of the rectangle, which is length times width. We're going to multiply these together and set it equal to the given area. So I have that written out. X times the quantity x plus 5 equals 36. To solve this, we want to make it look more similar to what we've been doing in this lesson. So we're going to take this x and we're going to distribute it. So when we distribute, we get x squared plus 5x. Okay, at this point, we want this equation equal to 0, so we're going to move this 36 over. And now we're going to factor using a t-chart. So we have 9 times 4 makes 36. And then we need 9x and 4x to make a positive 5x. So that means the 4 will be negative. So we end up getting x plus 9 times x minus 4. Using the zero product property, we can set both of these equal to 0, and when we do, we get x equals negative 9 and positive 4. Because x in this case actually represents a length of a rectangle, we can't use the negative, so we're just going to use that x equals positive 4. So our final answer is x equals positive 4.